All right, so welcome everyone to season 3, episode 19 of the RiSWP mentorship series. Today's episode is going to be the AI All-Stars. We're really excited. We have a really great panel joining us today. So first off, who are we? Who's hosting the show? So SWAN is the leading global hub for the water, wastewater, and stormwater sectors. And we're joined by our official affiliate RiSWP for all young professionals 35 and under interested in the smart water sector. So thank you all for joining us. A couple of quick announcements and events coming to an area near you in the coming months. We're really excited. SWAN is going to be hosting a workshop at the 8th annual California Water Data Summit. It's going to be all about intelligent questioning and sharing water wisdom. As I mentioned, we'll be hosting that workshop. We have a 50% discount available to all SWAN members, as well as special opportunities for young professionals. So if you're interested in that, feel free to drop me a line. We'll drop some links for registration in the chat as well. Coming up later in September, the SWAN Americas Alliance is going to be hosting its 4th SWAN Americas workshop with the theme being Rise Above the Noise. It's going to be taking place in Milwaukee, Wisconsin. It's going to be right around the same time as WEFTEC. So if you're planning on going to WEFTEC in Chicago, Milwaukee's right around the corner. We'd love to host you there. Again, we have special opportunities available for young professionals as well as special pricing. And then lastly, we're going to be jumping across the Atlantic. SWAN is going to be hosting the Digital Water Pavilion at Aquatech, taking place November 6th through 9th in Amsterdam. So if you've never been, this could be a really great opportunity. Do some touring, get some smart water networking done while you're there as well. We'd be happy to have you join us at the Digital Water Pavilion. Then for those of you who are looking to maybe develop yourselves as leaders within the young professional sector in the smart water sector, our Rising Smart Water Professionals Leadership Team is accepting nominations between now and September 15th. So if you or maybe one of your colleagues that you know is interested in really developing themselves as a leader, taking their career to the next step, this could be a really great opportunity for you. We'd be happy to receive nominations from any of our young professional SWAN members. So again, we'll drop some links in the chat. Feel free to reach out to myself or any members of the RiSWP leadership team if you have any questions. And now I'm going to hand it over to the host of our mentorship series, Jade Pereira of Jacob, so she can tell you a little bit about our series and who we have on today.
Thanks, Sandy. Hi, everyone. Welcome to our 19th episode. I'm seeing some familiar faces and names and some I don't recognize as much. So welcome, everyone. For those of you who don't know what this series is about, so we have this mentorship series to just chat with some leading voices in the smart water sector and get to have like a mentor-mentee type session with these professionals where we get to ask questions about certain topics. And then all of these are recorded and they're put on YouTube later. So if you miss something now and you want to go back, we'll be sending links out. And basically, it's meant to be really informal. I'll be asking questions to the guests. I've prepared some, but please feel free to put any questions you have in the chat, and we'll have an audience Q&A at the end where you get the chance to ask those questions. So before we begin, I'd like to request everyone to please, put down in the chat where you're from, say hi to everyone, introduce yourself. Yeah. All right. So let me introduce our guests now. So our first guest is Jim Cooper. So Mr. Cooper serves as the Global Director for Water Optimization at Arcadis with 19 years experience as a certified operator, professional engineer, and utility manager. Jim is a recognized industry leader, bringing a passion for people enabled by technology with an education and research background, including multiple degrees in civil engineering and artificial intelligence. He brings deep industry relationships as chair of the American Water Works Association, Engineering and Construction Division, advisory board member of Baywork, inaugural chair of the AWWA Digital Twins Committee, past co-chair of the Digital Twin Lifecycle Subgroup for the Smart Water Networks Forum, and chair of the Intelligent Water Infrastructure Committee for the Sustainable Water Infrastructure Management Center at Virginia Tech University. Next, we have Stephanie LeBlanc. Stephanie LeBlanc of Fletcher's Lake, Nova Scotia, is the Senior Manager of Information and Technology Services at Halifax Water, where she's accountable for the Project Management Office, Engineering Information, GIS, Kedar, IT, and Operational Technology teams. So she sets strategic direction for cybersecurity, data and analytics, automation, and artificial intelligence, collaboration tools, and innovation, including drones, digital twin, and metaverse. Stephanie's teams are dedicated to experience-inspiring transformation at Halifax Water, ensuring a total experience for customers and employees. So Stephanie has spent the former half of her career in IT consulting and latter half in the public sector, building effective teams, client relationships, and developing strategy and service delivery models. And lastly, we have Kedar. Kedar is a staff scientist at KETOS and part of the team that maintains the KETOS data analytics and machine learning platform. He works with real-time water data from industries, agricultural organizations, and water utilities and turns it into actionable insights. Last year, he proposed a geospatial solution to visualize lead service lines that won KETOS the Water Data Prize under the mapping category. Kedar is a Microsoft certified data scientist, Databricks certified data engineer, and has experience building and deploying machine learning solutions on all major cloud platforms. He earned his Bachelor of Science from the Institute of Chemical Technology in India and MS from Carnegie Mellon University, both in chemical engineering. So welcome all of our awesome guests with lots of great experience. I think I'm going to dive right into the first question, which is kind of to all of the guests, which is, how did you get interested in AI? I'll go with Jim first.
Sure. Great question. And hi, everyone. Nice to see all of you. So how did I get first interested in AI? Well, to be honest, it started probably, well, a long time ago. Almost 15 years ago. It was actually 2013. So 10 years ago, I did my actual first project with the water utility using AI. And back then, it was the idea of really applying data science principles with engineering was just this crazy idea, right? Everyone looked at me like I was crazy. But I thought, hey, there's some cool opportunity here. And it was something new. I was a young professional and thought, hey, why not? Let me push the borders and see where we can get. So that's how I first got started.
Nice. Stephanie, how about you?
Good afternoon or morning, depending on where you are. So I started my journey in the public sector, rolling out very large projects and trying to be able to support and get the knowledge out to, over 36,000 people. We were doing a very large rollout. And so my journey just began with playing with AI very much like Jim, saying, I think there's a better way and we can do this. And so looking in particular at chatbots, robotic process automation, we were doing in healthcare previous to water, a lot around imaging and trying to find tumors and kind of marrying that up with physicians. And so my journey just started with playing with AWS technology, then into Google, and then into the Microsoft stack and Teams and Power Virtual Agent and things like that. So very, very keen and like to get my hands in and play with this stuff. Even though I'm more at a strategy level these days, I still like to play and dabble.
Awesome. So lots of people just dabbling, just dabbling in it to see what it's like. Kedar, how about you?
In fact, as you mentioned, Jade, I started as a chemical engineer. I studied at Institute of Chemical Technology in India, and it was a very math-heavy program, and that certainly came in handy. Then I went to Carnegie Mellon, where I got my MS in chemical engineering. And while I was doing that, I worked on time series forecasting of temperature profiles of chemical reactors, all using just data-driven approaches. And while I was doing that, I took courses in machine learning, deep learning, applied data science. And then there was a lot of self-study involved as well. And over the years, I tried replicating certain tutorials, deep learning tutorials, AI tutorials, publishing my code to GitHub, web applications, And I continue doing that to this day. I think it's a process and I've been enjoying it.
Nice. Yeah, it's nice to see all the stuff you post on LinkedIn. It's good that you're sharing all of that information of the stuff that you're learning and where you're learning it from. And yeah, it seems like sometimes you pick it up in university, sometimes you pick it up while you're just playing around in your job. So I think before we go into any like real questions, I think the question to ask is, what is AI? Because you hear so many definitions of AI, machine learning. I think it'd be good to set the stage. Jim, could you, if I had to ask a question, it would be, how can you explain AI to someone who doesn't know anything about AI, a total beginner? What would you say?
Sure. Wow. So, it's really easy to hear a question like that. How do you explain AI to someone that doesn't know it? And to automatically go in the mindset of, goodness, that's like trying to explain how to build a rocket ship to a 5-year-old, right? It's so complex, it's so big, where do you even begin? But it's really not. I would almost equate what is AI to slicing bread, right? We've all seen people slice bread. We've probably all sliced bread. But when you see someone slice bread in a different way that has a better outcome, and you think, wow, that's intelligent, right? That's different than how it's been done before, and you have a better outcome. Well, that's something that we as humans observe as intelligent. So when I say, what is AI? I think there's 4 key components to it, and you can't have AI without those 4 key components. It's the ability to sense, reason, engage, and learn. All of those put together in a way that we as humans feel like is intelligent. And when a computer does that, we call that artificial intelligence. I think there's a lot of people out there that kind of use the term machine learning or ML and AI interchangeably. And I pretty strongly feel, again, just my opinion, but I pretty strongly feel that those shouldn't be used interchangeably, right? I've said a number of times, you can go out and buy 4 brand new tires and you don't have a brand new car. But in my opinion, that's taking ML and then claiming that's AI. Certainly it's a key piece of it. Your car is not going to do very much without tires, but it's certainly not the whole thing. So.
Great analogy. Next, Stephanie, do you see AI the same way? Do you put a different frame to it?
I do see it similar to Jim. I was part of a webinar with Gartner where they started to talk about, they said bifurcation, which is a very big word, but just basically AI maybe coming into 2 branches, one more along the productivity stream. So, making things easier, making them faster for customers, employees, those types of things, versus this game-changing AI. And so I think even as we get through the conversation, some of those things will come out, like what are the easiest quick wins or little steps you can take versus trying to think of how you'll revolutionize the whole water industry. And so I liked that kind of 2 streaming that Gartner was proposing.
I like that. Yeah. I guess I'm putting a bit of my personal opinion in this. I think a lot of the young professionals, like in this call today, especially being in the water industry, we need to take those small steps, more than think about the big picture AI. Yeah. Next. So I do we've had like this high level overview of AI. But we see all these specific terms like, machine learning, deep learning, neural networks, all of these things. And it's hard to figure out what all these different things mean. So Kedar, I'm wondering if you can sort of take us through, take us a bit more in depth into AI. What are the different parts of it? And what do all these terms mean?
Yeah, for sure. And, those are some really good ways of looking at and thinking about AI and machine learning from Jim and Stephanie as well. And I agree with Jim. I think both AI and machine learning are used interchangeably when they shouldn't be. But at the same time, machine learning is at the heart of AI. So I thought it would be a great idea. And let me just quickly pull up a slide, talk through this a little better. I think it will definitely help to understand what machine learning is in the first place. And simply put, machine learning is the process of fitting a complex mathematical equation or a model to real world patterns. And that's all it is. And there are three types of machine learning, three types of methods of doing machine learning. The first is the supervised learning method, and this is by far the most popular method. So anytime that you hear someone's working on machine learning, there's a really good chance that they're doing supervised learning. Under supervised learning, we collect historically validated set of examples and then pass those examples to our mathematical function or our model. And as we're doing that, we update the parameters of the model such that after having passed enough of these examples, the model is able to automatically discern patterns and make decisions all by itself, like in this example here. The second type is unsupervised learning, where we don't typically explicitly give the model labels or historically validated examples, and instead, based on some similarities and differences between the underlying data itself, the model is able to categorize all of that data into buckets. So that's unsupervised learning. And then there's this final category of reinforcement learning. It works kind of similar to supervised learning, but the only difference is that instead of explicitly giving the model labels, the model refers to its environment to find those labels, to get those labels. And some examples of reinforcement learning can be found in robotics, where people build robots, or all of these automated bot chess players that you find online. So there are these agents which use reinforcement learning based on certain rules and train themselves. But then the question arises, what is fx? What does the mathematical equation look like in the first place? And there are different families of models that fx belongs to. The most popular family by far is the neural network family, as you mentioned, Jade. And then depending on the kind of data that you have, you could use different flavors of neural networks. For example, historically, convolutional neural networks have been used for computer vision or image analysis tasks. Recurrent or sequential neural networks have been used for natural language tasks like language processing and speech recognition. And there's this whole new category of neural networks these days called the transformer-based models. And these are the ones that are in popular discussion. In fact, the GPT in ChatGPT stands for Generative Pre-trained Transformer. But that said, I do want to point out that there are many different model families out there. And in fact, sometimes tree-based models, they perform a lot better than neural network models as well. So that's machine learning in a nutshell, and I hope that helps set some context.
Great. Kedar, I'm just curious at this point, looking at all of that. Obviously, there's a lot to learn. Thanks for trying to condense everything into a 2-minute slide. How much of that stuff do you need to know before you start building an AI application?
I think it's definitely helpful to know, to have a lay of the land, to know what's out there before you begin, let's say, implementing machine learning in the first place. But that said, as I mentioned, some of the terms and the technology that we hear popularly on social media, transformers and adaptive training and all of that, I don't think they are very useful when it comes to applied machine learning. What's really helpful is to know these simpler models. So let's say simple linear models, how to program, let's say tree-based models, and they're relatively easy to understand. And I think even implementing and knowing about those simple models could go a long way in trying to deploy a machine learning based solution.
Got it. Okay. So there are simpler models that you don't need to understand all of AI to start working on something. Okay.
And in fact, sometimes they could be more effective than neural network based models as well. So that's a hidden secret that people won't normally tell you.
Got it. Okay. Nice. Next question, Stephanie, I want to go to you. What are some AI applications in the water industry that you're excited about?
Yeah, so there's there's so many places you could go, so many things you could do. I think sometimes that's probably the overwhelming part, when you're trying to get into this. So I'm going to stay more low key and leave Jim and Kedar to talk about maybe specific water, wastewater, because I'm only just past my year here in water and wastewater. But what we're seeing, there's a whole data and analytics piece, but the other piece is just around our workforce and the knowledge. So a lot of the knowledge is in people's heads. And so we've got to figure out how to get that knowledge either to our frontline workers in a new, innovative, and exciting way, whether that's through ocular technology or just on their phone through a chat bot or something that can help them quickly with what they're dealing with. And as well as our customers, right? So we're still very, in terms of having a service desk, people are wanting to get and bring in that information more easily, like without having to call or send an email, those types of things. So those are some of the things that we're seeing, as well as automations. There's a number of things that are very manual that could be brought forward very in a quick manner with the robotic process automation. So we're looking at a lot of those things. And to me, I really focus more on that productivity beginning, because it's such a great place to start. You're saying the small things. It's very easy to set up your first chatbot that's just a simple question and answer, or a knowledge base that you're pulling from. So, just some of those small pieces, but I'll leave Jim and Kedar to maybe get into some of the heavier water, wastewater algorithms that could be worked on.
Right. I think that's an important point you're raising, something that I'm thinking about now, because now when we talk about AI, there's like the AI applications where you're using a model to process water data, which is how AI has been spoken about for a long time. But now with like the rise of these GPT-like chatbots, right? There's like another application of AI which isn't exactly the same, which is just someone's built these large language model tools. Now, how do we use that to improve operations, improve communication, all of those things? So yeah, I'm glad that you're focusing on that aspect, Stephanie. Jim, how about you? What applications are you most excited about with AI?
Oh my goodness. I would answer that by saying, what applications are we not excited about for using AI, right? If we go back to what I was first saying, it's taking processes, calculations, decisions, interactions that we do today, and applying a technology to improve those in some way. So why wouldn't we want to improve everything we do? Now, of course, that's a bit of a, just passing comment, but a couple specific examples. There's so many out there, right? I guess before I get into specific examples, my point with all that is it's us as the humans, which are really limiting what AI can do, right? It's what we can think about and how we think about things are today, right now, which is scary to think about, right? But it's truly limiting. And ChatGPT, someone brought up, perfect example, right? What is the limiting factor of ChatGPT? It's us and what we think to ask it. It's not the output that it's giving us, right? Now, certainly it's not perfect, right? We know that. But it's the prompt engineering, it's us asking it the questions that limits its capabilities, which is crazy to think about. In that mindset, if we go to water, wastewater sector, right? Stormwater, when I ask anyone, how do you define data? 9 times out of 10 today, the answer is, well, spreadsheets, databases, numbers and letters, right? But how easy is it to put a thermal image in a pump station of all your pumps to get thermal imaging and use computer imaging to sense when you've got a bearing that needs maintenance or is going to fail because you've got a change in thermal imaging, or computer vision and signaling with a sound, right? A sound monitor to hear when you have a squealing. So you truly try to get to everything you could actually get from data when we walk in as a person, but we're not actually even thinking about that as data. If you think about that as data, all of a sudden, we can use all these different algorithms and tools that are out there that comprise AI to help us get answers. We just may not think about those in the past. Couple examples. So I think a pretty significant one is taking what I just described and having a maintenance digital twin that tells you for any specific facility if everything's good or if you've got some things that are not normal that you should go investigate, all the way to one of the most important roles, but entirely manual roles in treatment, is supply chain and ordering chemicals for treatment facilities. That certainly could be automated. Maybe reminders, maybe alerts, connecting to manufacturers and suppliers and bringing in all the capabilities and power of AI to make that a more automated process. So you don't have to worry about that. To forecasting, to process optimization, right? I mean, we could go on and on and on, but the capabilities are truly unlimited.
Nice. I have seen some of the big wins in AI for water lately have just been what you spoke about, which is like chemicals, like, optimizing the dosing for different treatment processes has been pretty successful in a lot of places. I think it's a really cool point, Jim, that you brought up about looking at things that we don't just see in databases and spreadsheets, like imaging, sounds, all of these things. If you can collect this data, this is the kind of stuff that we don't know how to process, but AI might be able to form those connections. Kedar, how about you? What are some real world examples of AI applications in water that you have seen?
So in fact, drawing along the lines of the dosing example that you just gave, Jade, I know that there are many correlative predictions that people are working on, which tend to be very, very effective as well. And what I mean by that is specifically, let's say in the realm of water quality analysis, where it's not always possible to measure certain parameters, let's say biologicals or some organics all the time. So I think if you are able to find a correlation between all of the parameters that you can measure and some of those that are difficult to measure, I think that goes a long way in trying to create a lot of value really fast. Then also, I know that, or that's something that I worked on earlier as well, which is lead pipe detection using machine learning algorithms. And there are people who are out there who are using machine learning successfully to inform or to improve the process of finding lead pipes really fast. And I think that's a very effective application of machine learning as well. In fact, machine learning appears in EPA's documentation when it comes to processes of finding lead pipes. And then also drawing from something that Stephanie mentioned about open models that can be made use of for in the field of water. And something that's top of mind for me is this news from NASA and IBM Research just last week, where they open source some of NASA's models for geospatial analysis. And I think remote sensing is something that personally excites me because I think that could go a long way when it comes to digitizing assets and monitoring assets remotely from the sky. So that's a space to watch at.
Nice. Very, very exciting. I think, all right. I see Juan has a question in the chat. Juan, we'll save it for the 10-minute Q&A session at the end.
Jade, I think you just went on mute.
Oh, I'm on mute. Sorry, there's like someone chose to cut some leaves and it's like a big blower in the background. So I'm trying to minimize the noise. All right. So the next set of questions is about developing these AI skills. How do we do that? All right. So the first question is to everyone, I guess. Maybe I'll start with you, Kedar, since you've been deep into actually implementing these AI technologies. What are some good resources to start to learn about how to apply AI?
Yeah, I think the first place that we should try to explore is to see if there are other people out there who are working on similar use cases in your line of work. And I think a lot of things can be done when it comes to that. it's great to just go out, attend conferences, get to learn from people about what are the things that they are working on, and then see if there are any parallels for you to replicate some of that work in your day-to-day as well. The second point that I want to mention is that machine learning as a whole is very transferable. And what I mean by that is, let's say a model that someone trained to differentiate between images of cats and dogs is the same technology that goes into, let's say, reading X-rays for healthcare and saves thousands of lives. So in addition to looking at all of the resources in your own domain, it could be helpful just to see what's out there. If you're working on, let's say, crack detection in pipes, then it could help to see what's happening in the computer vision space and what's transferable. In addition to that, if someone's interested in getting really hands-on, I would recommend picking up Python as a programming language. And there are many resources out there, and even a decently good resource can help you really learn to program fast. And tons of tutorials out there, and that's how I picked up some of these skills as well. Just go out there and try to see if you can replicate some of those scenarios for simple tasks, and I think that's a great place to begin as well.
Nice. Stephanie, do you have any good tips on where to learn about AI and how to develop those AI skills?
Yeah, I think there's a lot, just like use cases. There's a lot of places you could go look. To be honest, when I first got into this AI and chatbots is where I started. I learned how to, order flowers. So it doesn't even have to be about your industry. It's about, like Kedar said, like I had to reteach, I programmed my whole life, but now have not done that for a long time. But Python was new for me. But just getting in there and setting them up and seeing, okay, I can do something easily if it's just, A plus B equals C. But if I want some little logic, what do I do? I would just get into all the three. I mean, I'm sure you guys could tell me more technologies, but I mean, I started with AWS, went into Google, and then got into Microsoft stuff. So it's good to see what each of the big players have out there, but it is really easy to get in, even as young professionals, if you can do it through your business, or if you can do it even with your Gmail account, you can set something up for no cost and start playing with some of these tools. In Microsoft Teams, there's a Power Virtual Agent inside Microsoft Teams. It's free as part of the license to just play and see which technology kind of speaks to you. Along with, I only used Azure services for my machine learning, Kedar, but I'm sure there's other ones that people use. So I think there's just, Power Automates out there as well. So just kind of branch in there and just start poking and do some small little things. And like I said, it doesn't have to be, overly onerous. Mine was buying flowers and saying, no, I only have lilies, orchids, or tulips. It can be that easy to start.
That's a good point. You can go down the Python route and actually use the tool, use the algorithms that people are building in Python, or all of these, like you mentioned, Microsoft, AWS, Google, all of them are coming up with these AI packages that make it a lot more easy for someone to implement AI solutions. They kind of do a lot of the background work. Jim, do you have any other suggestions for the audience on how to learn AI?
I always have suggestions. If I give a lot, maybe some of them will actually be useful. So it's interesting. I pondered the question. You're asking about developing AI skills. So my brain went to, well, what is an AI skill, right? We've been talking about AI here for 30 minutes. We've named some programming languages, but we certainly haven't talked about schema and how to program anything. So what is an AI skill, right? And in my mind, if I look to the future, which I don't have a crystal ball better than anyone else, right? But if I'm a rising professional today and I'm looking at how do I get more into the topic of AI, I still go back to the coming up with very unique and innovative ways of how to apply AI is the most important skill you could develop. So how do you go about doing that? My suggestion is to give yourself some room to think about that and be creative. I think many of us are probably coming from technical backgrounds, maybe not all, but most of us probably come from a technical background, engineering, right? So giving some time to think about, well, what if we did this, or what if we had these different data sources? What are some things that we could actually leverage with technology that we're not doing today? How can we do things better? Then you say, okay, well, I have this idea. Let's figure out how we can use technology to apply it. Well, you're going to have tons of people, right? You can Google it, right? You can go on ChatGPT and say, how do I use technology to solve this problem, right? And it's going to give you the answers. So I think humans' piece in all this is identifying the opportunities. It's the critical skill.
Great. Okay, identifying opportunities, a good skill. So now, Kedar, I'm wondering, could you take us through, like, what does an actual project look like an AI implementation project look like from start to finish? What are the different steps? Maybe how much time are you spending on each of those steps?
Yeah, that's a great question. And I think, first of all, the workflow itself, the process, it depends on the use case at hand, the application. But there's a template more or less for an average AI project. And I think it should always start with the why. Let's first of all always know why you want to implement a machine learning project in the first place. And I think that decides a lot of other things, a lot of other decisions that you would need to make throughout the process, including what kind of models to use. If you need neural networks, or if you need tree-based models, or a simple heuristic, for example, in the first place. But once you have a solid answer to the why, we typically then start looking at the data itself and answering questions about the data, like, is there relevant data that's available? What's the quality of the data? And could we mine more data for the purposes of creating the value that we set out to create in the first place? And once that's done, then that's when we usually experiment with all of these different models that I just mentioned. Or first of all, I guess it always helps to start with a very simple model, build an end-to-end process of the entire workflow, how the final output looks like. And as Stephanie mentioned as well, let's try to keep it very simple, and that usually involves a very simple linear model or a heuristic, and that helps set expectations and gain clarity on the outcome of such a project in the first place. That's when we start exploring the different kinds of models, experimenting all of these different configurations, and seeing how we get the best performance. Then we deploy a model to production, using AWS or whatever other services you have at your disposal. And finally, you keep on monitoring the quality of the model to see if there are any drifts, if it's performing as expected, or if you want to pivot and take a different approach. And so as I mentioned in the beginning, it depends on the use case at hand, but I think this process is more or less helpful for any kind of ML project that you're implementing.
Nice. That's really, really good to hear about. I think, Juan, that kind of answers a bit of your question. So Juan's question was, what are effective tools for like knowing, having some quality control before an AI, like the AI applications are actually live and running? I think, Kedar, you mentioned a couple, right? Like just checking drift and things like that. Could you like say those things again? Yeah,
of course. And I think the second part of Juan's question is also the thought of using another AI to infer the outputs from the first AI, and doing that in an automated fashion. But as I mentioned earlier, after we deploy certain models to production, it's always better to, simply put, to see the distributions, the histograms, for example, in the data, and keep track of what the predictions are looking like. Maybe even involve a manual step where you pick out some decisions randomly and then see if they are making sense, or if not, take corrective actions. The second part to Juan's question, it's kind of interesting because that's something that people have been working on actively at this time. And for example, let's say you generate some text from ChatGPT or some other prediction from a model. Could you then use ChatGPT again to then inform if the first prediction was accurate in the first place and what was the degree of that prediction? I don't have a good answer to that. I'm still a believer in the old practices just because they're much more reliable. They have been studied a lot than all of these newer generative approaches. So I would say that I do tend towards using all of these other statistical approaches that I mentioned in the beginning over AI approaches for evaluation.
Got it. Use statistical approaches.
Yeah,
Best.
old school.
Old school. Okay, got it. I want to encourage the audience at this point to put any questions you have in the chat, and then we can ask those during the Q&A session, which is coming up soon. And if there aren't any questions, we can just continue with my own questions. I have plenty. So, I want to go to Jim next. So you've been working on implementing AI projects a bunch. What are some important lessons you've learned as you've immersed yourself in the field? I know you've kept hitting on a bunch of them as you've gone through this talk, but do you have any others to share?
Sure. Let's step back a minute and not talk about AI. Let's just talk about implementing any equation or any predictive model, maybe statistical, right? Anything, right? I don't think anyone that implements them expects the outcome to be 100% correct, right? I have a background doing a lot of modeling, right? And I start out by telling everyone models are wrong, right? We try to minimize how wrong they are. With AI, it's interesting because we almost have this expectation that it's 100% correct, right? So you set yourself up for 100% chance of failure if you think it's going to be 100% correct. It's not going to be, right? We want to improve on what we're doing, but you're not going to have the right answer every single time. And you need to design in that and consider that when you're implementing AI. So I think that's one of the key components. Another key component implementing AI is that everyone seems to feel that they don't have sufficient data, either quality, quantity, velocity, you name it, right? The big data component, they don't have sufficient data to actually start using advanced technologies like AI. And my answer to almost everyone that asks that, particularly in the water sector, is that, well, if you're waiting for perfect data, then you'll never implement these advanced technologies, right? You need to design that into your approach. You need to design that into your implementation, that you don't have perfect data, that you're going to have gaps, right? So you got to really go at it with a very practical mindset. And today, it's interesting because we tend to look at outcomes, right? And we think things like, I don't know, something that can predict process performance at a treatment plant, right? Or energy consumption. We look at that and are wowed by the outcome and the capabilities of the results, that we kind of tend to elevate the algorithm to be something that's so mind-blowing when really it could be just a really simple calculation that's giving a good result, right? So it's important to just, I guess, set expectations when you're implementing AI as to what it can and can't do and what the purpose is, right? Don't go in there thinking it's going to save the day. It might, but that's certainly probably not the original design or intent.
Got it. Yeah. Set expectations, factor in that it's going to be wrong a bunch of the time. That's definitely a very good point. Yeah. Stephanie, I'm curious about your experience with implementing AI, what lessons you've learned. Is there something in particular that you've experienced, like working in a utility, about implementing AI? Any lessons learned?
So I think, I agree with everything that's been said before as well. I think the two things that jump out at me that we kind of haven't covered is if you're doing this for your business and you're trying things out or whatever, be on top of all of the costs. So it's really easy to run a model, bring it up a search intent to go over all your knowledge bases, learning from experience, someone who woke up one morning and had a $1,200 bill for some things that she turned on to, try to enhance my knowledge base for my chatbot. There's learnings there that you have to keep on top of these things. They're web-based services. You're paying, by the transaction or by whatever. So just heads up. But if you keep an eye on it, it won't be a problem. A lot of times the big players will work with you. That in particular for me, they actually wiped that charge, knowing that I didn't know how much it cost when I turned it on. The other piece that we haven't talked about is cybersecurity. So we need to be careful what we're putting out there, what we're using ChatGPT for. I'll put that one out there. It does wonderful things, but be careful what you're putting in it, because now everybody else has that knowledge. And we've seen some people that are actually loading up databases, and it's proprietary knowledge. So we have to be careful. And as well, what it feeds back, because it's getting smarter and smarter, and now it can be emulating things to you, through email or whatever that answer is. It's could be skewing what you're seeing. So, as Jim said, take that with a grain of salt. Plus as well, there's lots of people starting to write code to start to attack using AI. So we have to be very cognizant of all of those things that are happening in the world. Just that little, I'm very excited about AI. I like it. I see lots of uses for it, but we do have to be cautious.
Yeah, Stephanie, that's great points that you bring up. A lot of young professionals will focus on like the small projects, the implementation, but you do need to keep an eye to like the bigger questions when it comes to implementing the stuff for a utility, like a government organization. Dax Blake has a related question. Dax, I'm wondering if you can unmute yourself and ask it.
Wow, I didn't know I was going to get to speak too. I was just really kind of looking at like AI and operations, at having a little bit of experience on the public side and dealing with treatment plants and operators and the like. They can be a challenging bunch. And so, taking AI to this group that's typically less sophisticated than say like a data analyst or somebody that's coding in Python. What kind of challenges and how do you gain adoption and what can you do to build their trust in these types of solutions and get them to apply it? And does anybody have any good success story that they can, point to or share?
Wants to go first, Jim? Yeah, okay.
Sure, I'll go ahead and start. So I guess we can take the last 10 minutes just talking about, no, I'm just kidding. So a couple thoughts, right? One is, in general, we are all collectively as a part of the water sector, which is one of the slowest sectors to innovate of everything out there. So we need to recognize that, right? I think that people, whether it's an organization, whether it's individuals, whatever, go and try to take something advanced like AI to operators at a treatment plant. There is significant hesitation to the point where they just simply decide, no, we're going to continue to do things the way we always have done it, right? So one of the approaches that I've seen be quite successful, and it's not a new term that I came up with or Arcadis came up with, it actually MIT came up with it, but it's called collective intelligence instead of artificial intelligence, where it's you combine AI with human intelligence to collectively have a better answer than you would either would on its own, right? So working with operators, it's a very different approach to go in and say, hey, we're going to bring technology and it's going to tell you how to do everything, versus, hey, we're going to take your role and make it so much more valuable because you're going to apply this tool that you now have in your toolbox to improve performance, save cost, right? Put the value with them. I mentioned this in the past. One of the huge hesitations that I've seen and observed is that when you get to the frontline staff, the frontline operators that are not making strategy decisions, but they're pressing the buttons on everyday, decisions for pumping and whatever treatment, they place the greatest value from themselves to the organization on the data that they have access to. So they think it's great when a superintendent or someone calls them up and says, hey, we have this issue, tell me what's going on, what are you seeing in the data, right? They see that as value. When you bring in technology and all that data goes to the technology, all of a sudden as individuals, they think, well, what value do I have to the organization, right? I'm not the one that now has the rights of that data. Everyone does, right? The computer can get it, anyone can see it, right? So you really got to turn around the discussion of, okay, well, that's, we're not taking away your value to the organization. Your value is actually a lot more important now because you have the opportunity to be the one to analyze and give the output of that data, right, to those people, right? So it's really just, it's a fine line balance between AI coming in and threatening frontline operator staff and being supportive and helping them and bringing them more value to the organization.
Nice. I want to share with everyone too. Vito brought up a good point in the chat as well. He says the best way to gain traction is by building trust through transparency. Vito, do you just want to unmute yourself and share that with everyone?
Sure. Yeah. We often get the response that people don't like the black box approach. They like to have a good understanding and transparency into how some of these solutions work. So just providing the proof goes a long way.
Got it. Providing proof. Nice. We're almost at the end. We're almost at the end of our session. Maybe I'll end with one final question. Maybe I'll just ask Stephanie. There are a bunch of young professionals on this panel. What do you think the future? How do you see the future of AI in the water industry, and where do you think young professionals fit into all of this?
I think young professionals are kind of the key to all of this. You've kind of grown up with technology, which some of your counterparts that maybe your bosses or, running the organization haven't. And I think you bring a lot. You're not afraid of it. You'll dive into it. You'll play with it more. And I think you can really kind of spurn that fire in the rest of the organization by showing those small, quick wins in some of the things that you'll dive into and look at, as well as your communities. This is a wonderful community for you guys to start sharing your ideas, to reach out to people to see how do they get started, even in a small way. There are a number of innovators out there willing to help, as well as all your YouTubes, and there's probably even TikToks on how to do AI these days. But I mean, you're the future. So I look forward to what you guys will do with it next.
Great. I think that's a great note to kind of end on. Sandy, do you have any final thoughts?
No, just thank you to Jade and to all of our panelists for really sharing your insights. It was super interesting. I took a lot of notes. I'll try to share some of them with our wider community tomorrow. And thanks to the audience as always for all your questions and making these panels as great as they are. If anyone has any ideas for future themes, topics, we're always open to hearing from our audiences. We'll also be sending an email follow-up with the recording. So if you like what you heard, don't be shy, share it with your colleagues, let them know what we're doing here at RiSWP. We'd love for more young professionals to be involved with us. And yeah, thank you everyone so much. Have a great day and see you on the next episode.
Yeah. Thanks everyone.
Thank you, everyone.